Hi everyone. So this particular recording is about uh, activation function. We'll try to understand what is activation function, what is the importance of activation function, and we will extend the example to understand what is a loss function, what is a learning rate, what is an optimizer, and regularization. These concepts are very critical when it comes to the concept of neural network. So, activation function, as the name reflect, it talks about activation, right? In a way, activation function is a function that activates a particular neuron. It decides whether a particular signal which is injected in the system, or it's an input to the system, how that particular input will be processed. It's a mathematical function wherein uh, we bring multiple signals, multiple decision making aspects. We club them together and take a decision. So let's try to understand using this analogy. So let's assume that we are in a restaurant and we are uh, planning to order for a dessert. You are the one who is supposed to take a decision, and uh, maybe your decision will be impacted because of how the dessert has been explained to you by the by the attendant on the table. Uh, Maybe the meal that you had, whether you had a large filling. If it is a large filling, it can send you a negative signal that you're full. Maybe there is no space for dessert. Or maybe the photographs which are given in the menu, they are compelling, and they're sending a positive signal to you, and maybe you are getting tempted to go for the dessert. And then there is a possibility that maybe there is some condition, some medical condition, a lifestyle challenge, and because of that you want to cut down the sugar, and in a way that advice that has been given by the doctor is going to act as a negative signal. Now the decision making is not so simple, right? We understand when these different signals um, they they uh, uh, they 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 come in your thoughts, right? They have got uh, different impact, right? And when you say different impacts, it's kind of a weight that you attach to each signal, right? And then you can have your own preferences, and you can call these preferences as bias. Let's understand this further. So what actually is going to happen when these four different signals will reach your brain or the neural network? It will be, every signal will be assigned a different weight. And in case the overall impact is positive, right, there is a possibility that you will order a dessert. And in case of the overall impact of these weights and signals is negative one, then maybe you will drop the idea of having a dessert, right? So activation function is the function that actually does this for you. It brings all the signals into consideration, assign a weight to them, right, and assign a bias, do the mathematical calculation, and send a yes and no kind of signal further. So this is a very simplistic definition of activation function. And the activation function, they're pretty important, um, in the sense that they bring non-linearity in the system. When we say this, consider that in case your decision making is only driven because of one single signal, say the doctor advice, or maybe the way the desert has been explained to you by the attendant. If it is the only signal that you are supposed to process, the decision is going to be so simple. It is a linear kind of decision making. But we know that in real life, it is not. It's not so straightforward. There is a lot of non-linear inputs will go into the system. And when we bring activation function, the overall neural network, in a way, it powers it, right? And some of the critical decision making, like for example, identifying the objects, identifying the faces in the images, understanding and translating human language, making accurate decisions when it comes to stock market, right? And all of these things are driven through different algorithms, different models. So in a way, activation function makes this possible. Now let me extend this example, and let's try to understand what is a loss function. Now, when you when you have taken a decision whether you want to go with the desert or you want to drop it, there is a possibility that you will come back and maybe you will regret the decision that you have taken. Maybe you're not liking the decision. Maybe once you had the desert, you have a feeling that there was too much sugar, or maybe you did not go with the decision, and later on you regretted that there was some scope. You could have gone with it. So this is uh, uh, the loss function, right? Wherein you have taken a decision, you have done a prediction, but it is the actual one is different. So this defines the difference. I mean, the difference between the actual output versus the predicted output, that defines the loss function. Let's come to learning rate. Now you want to improve your future decisions, right? And in a way, you will learn on the basis of the decision that you have taken. So in it is possible that you may overreact. Next time you probably will reverse your decision, or maybe you will go slow. You will continue with the same decision. Again, all these are driven through your learning rate. So the right learning rate means that you adjust enough based on your experience. Right? So how do you do that? How do you ensure that um, the regret that you may have because of the decision that you have taken, how are you minimizing it? Right. So every time this process is repeated, in a way, you have to go back to this function and and uh, uh, improve the overall decision making, and that comes with the learning rate. Let's talk about the optimizer now. So consider that optimizer is a kind of an inner coach uh, who is helping you to understand that okay, there is a regret at your end. Now how will what are the changes that you will bring in your decision making? Okay. Maybe the way the weights, different weights were applied, maybe the way the bias was applied, right? Maybe those needs to be revisited, they needs to be adjusted, right? If you got carried away with how the waiter or the attendant, he or she described the the dessert, maybe you in the future you probably have to ignore the enthusiasm, right? You have to go with your own guts, right? So in a way, optimizer will help you take the right decision by revisiting the weights and bias that you have applied to each and every signal. Let's talk about the regularization now. And regularization is, let's assume that you ordered for a dessert, maybe it's a chocolate cake, right? And you liked it. So and you start repeating it again and again. So regularization function is, and this is an example where overfitting is taking place, right? So regularization will ensure that you are being realistic. The decision making is being realistic. It is not sticking to one particular choice. uh, if today you have ordered for chocolate cake, maybe tomorrow you probably will, there is should be a possibility that you say that no, I do not want to go with a dessert, or maybe you want to order a different dessert altogether. So this is where the regularization comes into the picture. Now all these concepts are very very critical for us to understand, because they form the basis of how the neural network works. In the next session, in the next video, I'll talk about how these come together. Thank you.